Okay, so this is about how we can do the aggregation. So what is aggregation? Aggregation means I want to know the mean, or I want to know how many times the count. I want to know the maximum. So I want to know the size and etc. Okay. So at the first part, I specify uh, this one. Yeah, I can see how many. So using count, what is the first item? What is the last item? So I can see the mean or the average. I can see the median. I can see the minimum, the maximum, standard deviation, variance, MAD, the mean absolute deviation. Prod means the multiplication product of all items, and sum. So I want to do the summation of all the items. So this aggregation works for the numerical data. So let's see if I do the simple aggregation for the order. Okay. So, okay, this is the merge data. Let me just use the orders. So in the order data, there is a column price. So I want to know what is the average of the column price. Then I will type the DF order, the column price, and calculate the mean. So the mean or the average price is 13.75. So this is based on this data. So 10 plus 15 plus 20 plus 10, then we will do the average. What is the maximum? Then we can check the maximum is 20. And we can do group by. So what we will learn today is about the group by. So we want to group by the product. What is the product? This is the column product. So we want to group by the product, and then we want to check the size. So it means I want to know how many for the product. And then I will make the index starting from 0. So the index will be reset, and the name of the column will be order count. So you can see the product name, laptop, the order count, there are 2 laptops. Okay, so we have 2 laptops. Laptop, laptop. So there are 2 laptops. So we do the aggregation. And we can see that there are 2 laptops and there is 1 phone and there is 1 TV. Okay. So we will do more with the group by. Let's say we want to group by with 2 different columns. Okay. So I want to group by the users and the product. Then I will group the 2 columns and I want to check the size. So in this case, if I do with the user ID and the product, so each of this will have 1. Each of this will have 1. Each of this will have 1, and each of this will have 1. Okay. Now, because doing this kind of group by is not good with small data, so let's do with a big, not that big, but this is quite okay. Okay, the size is quite reasonable for doing the analysis. The data set name is miles per gallon, or sometimes we call it MPG. The data concerns city cycle full consumption in miles per gallon. It is to be predicted in terms of 3 multi-value discrete and 5 continuous attributes. So MPG, miles per gallon. It means 1 gallon, maybe if we in Korea, we usually use liter, 1 liter. So 1 gallon, how many miles your car can go? Maybe in Korea, 1 liter, how many kilometers that your car can go? So there is a data. This is the continuous data. So the MPG, it means miles per 1 gallon. Cylinders, it is multi-value discrete. Displacement, it is continuous. Horsepower, this is the power of the car, continuous value. Weight, this is the weight of the car, continuous values. Acceleration, so how fast the car from the starting point, it is continuous value. Model year, so it is the multi-value discrete. Origin, multi-value discrete. And car name, it is string, unique for each instance. So there is a note, there are some missing attributes. So in the horsepower, there are 6 missing values. Okay. So this is the data. So using the group by, we want to look at more informative data. Okay. So group by is a powerful method used for grouping data based on one or more criteria and then performing operation on those groups. So this is the data of MPG. So 18, it means for 1 gallon, the car can run for 18 miles. So let's see this one, 15. It means for 1 gallon, the car can run for 15 miles. So which one is more efficient? This one, the 18 is more efficient because for 1 gallon you can go longer. Okay. This one, 1 gallon, you can just go 15 miles. If you just go 15 miles, then it is not efficient. So the last value, if it is 1 gallon, 1 gallon is 10 miles, then it is not efficient. If 1 gallon is 20 miles, okay, then it is better, or this is more efficient. Cylinder. So the data is about the car cylinder. The cylinder is 8 and so on. Displacement. So this is about the car. Maybe about, if you look at the car, I don't know what is the Korean. Displacement. Okay. So this is the displacement of the car. So they have the data, the displacement is 307. Okay. So it is like the displacement power or something. And then the horsepower. So the horsepower is the car power. The weight, the car weight. So maybe this is in kilogram, 3,500 kilogram. Acceleration. So how fast the car in what 100 meter. And then the model year and the origin is from USA or from Europe or from Japan. And the name of the car, it is Chevrolet Chevelle Malibu. The name is Box Skylark 320 and so on. So using this data, we want to do the group by. So let's do with the column origin. In the column origin, it is, if you look at this one, the origin is a multi-value discrete. So it means this is a categorical value. So the categorical value, we have multi-value, not only one, then we have several values. So in this case, if you check the data later, we have USA, we have Europe, and we have Japan. So the question, okay, so maybe in the exam, I will give you like this question. I have this data and then describe the data for its origin. So you need to write the code. Group by the origin. Show the mean for every numerical data grouped by the origin. Show the statistic mean median for the column MPG grouped by the origin. So how many data for each category in the origin? Okay, so I will give you a question like this, and you need to provide the code. Okay. So let's see one by one. Describe the data. I'm going to load the data from the Seaborn. So I'm using the Seaborn dataset. So load the dataset MPG. So let's look at the first 5 data. So this is the first 5 data. We have MPG, cylinders, displacement, horsepower, and so on. The one that we already looked at the column in the PowerPoint. And then I want to describe the data. So we can see here, in this data set, we have 398 data. So 398 rows. And the mean for the MPG is 23.51. The standard deviation is 7.81 and the minimum is 9. The Q1 or the quantile 1 is 25%, is 17.5. The median is 23 and the Q3 75% is 29 and the maximum is 46. So you can look at the other data set. So all those are the numerical data set. Okay. Now let's look on the details. This is the description for all the columns. You can do with dot T. What is dot T? It is the transpose. Transpose means you just change the row and the column. As you see before, we have the column name, the column name of each attribute. Now it becomes the row, and this statistical information becomes the column. So this is the transpose. Okay. So I want to check the information of the data. You can see here we have 398 data. So for the MPG, we have 398 non-null. 398. Okay, we have 392. So it means we have some missing value. Okay. Then here you can check. You can do something for this missing value. The remaining data, they are just complete. 398 data. So let's just, I don't care with the missing value. You can do with the missing value handling. You can remove it. You can change with the min, or you can change with 0 and etc. Now, I want to group by the origin. So I want to answer this one. Describe the data for its origin. Group by the origin. So group by means, yeah, I want to group by the origin. So you can do this one. Unfortunately, you cannot get the result. Why? Because once you create this group by, it is another kind of data frame. So you need to have more function. You need to have more details. Let's say I want to describe. Okay, so I want to group by on the origin, and then let's describe the data. Then I will do the group by origin. It is group by Europe, group by Japan, group by USA. So the car where the data origin equals to Europe, there are 70 data. Okay. And then the mean is 27.8. And the standard deviation is 6.7, and so on. Okay. So we can get the MPG, the cylinder, the acceleration, the model year, and so on. Okay. Of course, this is complicated. If you have all the data here, yeah, maybe you want to make a transpose. Okay, then yeah, you can check for each of the column. For example, MPG. For the MPG, you can see the Europe. Okay, there are 70 data cars from Europe. There are 79 data cars from Japan, and there are 249 data cars from USA. And then the mean of MPG is 27. The mean of MPG from Japan is 30, and the mean MPG for cars from USA is 20. Then we can do the analysis. Which car is more efficient? Before we say that the efficiency it is based on the high MPG. So the higher MPG means it's more efficient in the fuel consumption. Then, okay, car from Japan is efficient than the Europe and USA. Okay. And the other data is about the cylinder, displacement, horsepower. Okay, so you can see if the horsepower, okay, the car from USA shows has more power than the car from Europe and Japan. And you can check if the weight, the car weight from USA is the highest among the other countries. So from Europe is this weight, and from Japan is this one. And the acceleration, the model year, maybe the model year because it is based on the year. So it is, we need to check later about the proper value. So group by should be followed by a function. Okay. So when you do the describe, so we can do the description for all the attributes according to the origin. So we can do with a function, for example, min. Yeah, I want to see the average for every numerical value. So in this case, I want to specify numeric only equals to true. So I want to get the average for all attributes and group by the origin. So this is the average of the MPG for Europe. This is the average of cylinder in Europe cars. This is the average of the displacement of Europe car, and so on. Okay, so all of these are the average or mean. Okay. If you want to specify only a specific column, then you can do group by. Now I'm going to group by the origin, and then just look at the column MPG. the column MPG will be shown, and I want to see only the mean. Then this is the mean. This is the average. I want to see based on the median on the column MPG. So this is the median for the column MPG. And I want to know how many data are available in each of the group. So in origin, I want to see the variable or the value of the data and about the group. So here I want to see what is the value, which is Europe, and I want to see the shape. So it means we have 70 rows and 11 columns. Japan, we have 79 rows and 11 columns. USA, we have 249 and 11 columns. This is just for formatting to make it a better display. So I'm using the string function. Okay. So the string function, it is to show when you print the method, which is the value of this one, and then you will give 10 space. Okay? You will give 10 white space. So this is 10 white space. And after you have the 10 white space, you will specify the shape. The shape will be the group.shape. The group.shape is this one. Shape will be 70.9. So in this case, we have 9 columns. Oh, we have 9 columns. Okay, we have 9 columns. Okay, so this is how we can do the group by origin with some statistical values. Then you can see, show the mean for every numerical data group by the origin. So you can use this one. And then if you use only the MPG and you want to see the mean, you can specify the column name. And then show the statistic mean the median for the column MPG and group by the origin. So we just specify with the column MPG, and we can use the mean, you can use the median. And how many data for each category in the origin? So we can use the for loop, and we can do the group by for each of the origin. We want to know the shape. So we can do with the aggregate function. So it is the same as the group by, but we are going to have some multiple statistical metrics. Okay. Let's see here. I have questions. Show the minimum, the median, and the maximum of all numerical columns grouped by the origin. So I can select. Let me make a new variable. So the MPG, I will select the D types. It means I want to select the data types, and the data type is number. Okay, so numbers means the numerical columns, and the column that I want to check, let's put it into this variable. And then I would like to group by the origin, and let's put all the numerical values and do the aggregation based on the minimum, the median, and the maximum. Okay. Minimum, median, and maximum. The second one, show the minimum of MPG and the maximum of the weight grouped by origin. So show the minimum of the MPG and maximum of the width. Okay, so let's see the code. So I want to aggregate, and first I will just select the numerical columns. So selecting the numerical column means, yeah, I will just include np.number, and then I check what are the columns. So the columns of the numerical are MPG, cylinders, displacement, horsepower, weight, acceleration, and model year. Now I want to do the aggregate. So group by the origin, and then I'm selecting all the numerical column. So all the numerical column, it means this one. And then I will do the aggregate. The aggregation is based on the minimum, and then the second based on the median, and the next is based on the maximum. Now let's pay attention on this one. So there are three ways to explain this one. The first, you can specify the minimum with quote. So Python can understand that you want to select the minimum. The second one, you can specify with NP. So NP means the function from NumPy. So you can specify np.median. So it is a function to find the median. Or you can just specify the function, for example, max. So you don't need to put the code, you don't need to put the NP, just specify max. Okay. So for the basic information like this one, let's say the mean, the minimum, and then the mean, which is the average, and the maximum, which is the maximum, and the median. So for this basic function, you can use those kind of methods. But for the other functions, you need to specify later. For example, yeah, you want to know about the standard deviation. So the standard deviation, maybe you need to put the np.std, okay, and so on. So in this case, I want to know the minimum, the median, and the maximum for all the numerical columns and group by the origin. So we have MPG. In the MPG, I look at the Europe, Japan, and USA. So the minimum is 16.2, the median is 26.5, and the maximum is 44.3. For the cylinder, the minimum is this value, the median is this value, and the maximum is this value. The displacement, we have minimum, we have median, and maximum. For the horsepower, we have the minimum, blah, 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 because it is too long, okay? Because it is too long, so the space is not enough, so they put the dot, dot, dot like this. So you can just make it short. For example, I want to group by the origin, and then I want to aggregate only based on the MPG. And the MPG, I want to use the minimum, and the width, I want to use the maximum. So you specify the column name, and you specify the function. You specify the column name, and you specify the function. Then you will get, for the Europe, the MPG minimum is 16.2. For Europe, the maximum width is 3,800 something. In Python, you need to understand how to use a function. We call it lambda. Lambda is a function. So lambda function is just like a normal Python function. So I explained this one for you who have not learned Python before. It is a kind of function, except that it has no name when defining it. And it is contained in one line of code. So let's say you have x equal to lambda a, where a will be a plus 10. So we can specify print x, and when we put the value inside of the parenthesis. So x 5. It means this 5 will be the value of a. So a, which is 5 plus 10, then the result is 15. Now we have another function. The function lambda, we have a and b. So it means there will be two values. And the function will be a multiplied by b. So we have x 5, 6. A is 5 and b is 6. Then we have 5 multiplied by 6. The result is 30. Now we have the lambda a, b, c. So we have three values. 5 will be for the value of variable a, 6 will be the value of variable b, and 2 will be the value of variable c. So what is the result? This is 5 plus 6 plus 2. 5 plus 6 plus 2, then this is 30. Okay. So that's the meaning by lambda. And we can create another kind of function with this lambda. So let's see. If you have a plus 10, this is the function when you give only one value. So the result is 15. When you have a and b, it means you will give two values. So the result will be 30. And when you have a, b, c, so the function a plus b plus c, then it will give you three values, 5, 6, and 2, and the result will be 30. Okay. Now, it's getting more complicated. We have a group by, and we can do with transform. So transform means it uses the function transform to result a value based on a formula. So you can specify the formula by your own, or yeah, you can make function. So in this case, the function will be the lambda. So you use the dot transform when you want to perform a group specific calculation and have the result line with the original data frame. For example, you want to fill in the missing value with the group min. So let's say there are some missing value in the horsepower. Okay. So if you do with fill missing value, if you fill the missing value with the mean or with the average, so it is just the general mean. But if you can fill in the missing value with the mean from the origin, so if the missing value is the car from Europe, then I can check the data or the statistic, the average from Europe. If the horsepower which is missing is the car from USA, then I can check the mean from USA. If the horsepower that is missing is the car from Japan, then I can check the missing value horsepower from Japan only, and then I fill in the missing value with the mean from Japan. So those kind of thing is necessary, and we can do with transform. Now in this example, I want to use the normalization. what is normalization? So the normalization means I want to do like this function. So the normalization, it means I have the x data, and then I want to check the average x dot min. So let's say if I have data 1, 5, 3, 4, 2 like this, then what is the mean? The average is 1 plus 5, 6, 6 plus 7, 13, 13 plus 2, 15, 15 divided by 5, then the result is 3. Okay, the mean is 3. Then in order to normalize, so I will do the 1 minus 3, and then 5 minus 3, 3 minus 3, 4 minus 3, and then 2 minus 3. Okay, we can get this is the normalize. So 1 minus 3, it is minus 2, 5 minus 3 is 2, and then 3 minus 3 is 0, 4 minus 3 is 1, 2 minus 3 is minus 1. Okay, so this will be a normalization value. And we want to normalize the MBG based on the origin. And we need to check the average based on the origin. Let's do this one. So we do the transform. We transform the MBG based on the origin. And then the transformation, it will be based on the function lambda. The lambda x is x minus the mean of x. So the mean of x means this is the data, the mean from the origin. So if you run this one, then for each row from the MBG, now it has been transformed into the normalized value. So the first data, the normalized value is minus 2 something. The second data, the normalized value is minus 5 something. The third data, the normalized value is minus 2 something, and so on. Okay, so in this case, we use the transform and we use the function. So there's another kind of group by, we call it group by with apply. Group by with apply means when you need more complex and custom operation on each group. So the custom operation on each group that might result a single value or a series or a new data frame structure per group. Okay, let's see. So I want to see the find the index of the row with the maximum MPG. So I can see the maximum MPG is it was like 43 something. Okay, if you look at this one, the MPG, the minimum is 16 for Europe, Japan is 18, and USA is 9. Okay. So if you look at the data here, let's see this one. Okay, for the MPG, the maximum is 44 for Europe, Japan 46, and USA is 39. So the highest is 46. Okay. So I want to check where is the data when the MPG is the highest. So yeah, we can use the index of the highest MPG. It means I want to check from the column MPG, and then I will do the IDX max. So you can check this one if you want to know the MPG dot max. So the maximum is 46.6, but I do not know where is this data. So I can use the IDX max, and okay, I know that this is in the row 322. Okay, so if you want to look at this one, yeah, you can use the MPG ilog. MPG ilog. Yeah, so this is the MPG ilog row 332. Okay, so the MPG is 46, cylinder is 4, and so on. Okay, and then let's say I want to check from the origin. So group by the origin and use apply to get the first row of each group. So what is the meaning by the first row? The first row means the position or the index is 0. Okay. So the one that I showed before, I want to see the index is 322. This is from the data MPG. Yeah, actually you can also do like this T. Okay. You can we transpose or no? Okay, it's not available for the transpose. So I want to see where the data is in the position index 0. So let's group by the origin and apply the lambda x, and we use the index 0. So for Europe, this is the data in index 0. For Japan, this is the data in the first index. And for USA, this is the data of the first index. So we can make more complicated. For example, I want to apply this formula. So I have a formula to indicate that the MPG, the miles per gallon, is a function of this one, 37.23 minus 3.88 multiplied by the weight minus 0.03 multiplied by the horsepower. So this is more complicated. So calculate the predicted MPG using a lambda function. So this MPG, it can be the prediction value. So the prediction value based on this one, now I want to make it into 2 columns. After I have columns, calculate the difference between the actual MPG and the predicted MPG. So the first, I will create a new column, predicted MPG. And then I will do apply. What is apply? I would like to apply one value. So there is a value row. So let the value row, this one is a function of this multiplied by this one and multiplied by this one divided by 1000. And then we apply x is equal to 1. So x is equals to 1 means the column. So after I have the predicted value, next is I want to see the difference. So the difference means the MPG minus the predicted MPG. So this is the actual. And then after that, I want to show all the data. There is the MPG, horsepower, weight, predicted MPG, and MPG, the difference. So let's show the first 5 data. Okay, this is the actual MPG. This is the actual MPG. This is the predicted MPG based on the formula. And this is the difference. So the difference is MPG minus by the predicted. MPG minus the predicted, and this is the result. MPG minus by the predicted, this is the result. Okay. And the last one, we can do the additional aggregation. In this case, we are doing with cut and Q-cut. Cut means we will cut the data. We know that the MPG, the value is start from 0 until 46.6. This is the maximum. So I want to cut into 2. Okay, MPG in 2. So I want to cut. The first value will be between 0 until 23. And the other value will be from 23 until 47. The second syntax, this is to cut the MPG into 3. So cut the MPG into 3 bins. So they use the 3 equal bin. So bin, something like this one. So they have the measure about the bin, what is the range of this bin, what is the range of this bin, and what is the range of this bin. If it is from 0 until 46, so they split into 2 and 3, then they will have the distance from this one, distance from this one, and distance from this one. Or we can use the Q-cut. So Q-cut means from the quantile. If the quantile is 2, so it means we want to use the median. So the bin will be unit 2. So it is based on the 50% of the quantile. If it is 3, then the percentile is 33%, and then 66.7%, and so on. Okay. So let's see. We can do with cut. So after we do the cut, now the first data, it is changed into 0 until 23. We know the first data is 18. So 18 is in the group of 0 until 23. The second data, it was 16 something, and it is in the group of 0 until 23. So we want to group into a certain range. We have MPG in 3, so we want to make into 3 bins. So the 3 bins, it means there is a certain value. Say they calculate based on the bins, how many value in between 8 until 21. So what in the row 393, it is the value in between 21 until 34. And if we use the Q-cut, means we will use the quantile. If we use 2, then it means based on the median. So based on the median, okay, this value is in between 8.99 until 23. The value in this row, it is the value in between 23 until 46.6. Okay, I think that's all for today. So